Translations. Let's slide a figure. Up, down, left, and right. And a certain amount of units, too. We're going to slide it up, down, left, and right. You guys knew reflections. I never wrote out the word reflection. What symbol did we use that said, hey, you're about to do a reflection? What symbol? Lowercase r, right? That was automatic reflection, lowercase r. Unfortunately, there's 3 different ways I could show you a translation. All right, 3 different ways. First way is what I call function notation. Function notation. It'll say, all right, you're going to take your XY coordinate and do the following. You're going to see the implies arrow. And it's going to say something like this. And this is just an example. X plus 2, Y minus 3. So it's going to say, take your every coordinate you have right now, add 2 to the X, and subtract 3 from the Y. So what is that? What I want to talk to you guys about is, what directions are we going when I write that? What direction? Plus 2, X plus 2. Where am I going? Up, down, left, right. X plus 2. Think about your x-axis. Right 2. So this is saying, hey, all your points are going to go right 2. And then when you see y minus 3, what do you think's happening? Then go down 3. Because when you're doing a translation, you're sliding up, down, left, and right. So that's what this would mean here. Everyone take all the points, go right 3, right 2, down 3. So that's called function notation. Second one, vector notation. Vector. All you're going to see, and I don't know why they use these symbols here. They're inequality symbols, but they do. You're just going to see 2 numbers inside. That's it. That's called vector notation. I'll describe what a vector is later on in class. But you're just going to see the 2 numbers. And you know it's a translation. What's the 4 telling me? What direction? Right 4, yep. So this is telling me, hey, all the points are going to go right 4. Bless you. And what about the negative 1? Down 1. I just want to make sure we're all good where you're moving in what direction. Okay? So that's called vector notation. And the last type of notation, it doesn't have a name, unfortunately. Like lowercase r was for reflection. Translation, sometimes you'll see capital T. You'll see capital T. And yeah, that's how I roll. I put the fangs on there, all right? Every year I get criticized by students. Relax. That's how I roll with my capital T. How are you going to know up, down, left, and right? You'll see 2 numbers in the subscript. 2 numbers. So say I put 2, 2 there. Where are you going now? Right 2, up 2. Right 2, up 2. Yep, every point. So there you go, guys. Those are your 3 ways you could see a translation written. Function, notation, vector, and then capital T. Whew! All right, take a breath there. Let's see. Can we see if a translation is going on or not? Pre-image. I got square ABCD. Maybe I did a translation to it. Maybe. And got square A prime, B prime, C prime, D prime. How are we going to know if I did a translation or not? Every single point has to be moved the same distance and direction. All of them have to be moved the same distance and direction. So start with A to A prime, everyone. I'm going to ask somebody, first question of the day. From A to A prime, tell me the distance and direction you're moving to get from A to A prime. Right, left, up, down. Give me directions here. From A to A prime, how many units am I going and in what direction? There I go. Ready, Sabrina? Right, how many? Sorry, let me get it back up here. From A to A prime, where am I going? Right 6, down 3. Right 6, down 3, which means I better go right 6, down 3 to get to B prime, C to C prime, and D to D prime. If I go right 5, down 3, not good. It's not a translation. So everyone go ahead and test. For every single one of those, am I going right 6, down 3? What'd you find out? What'd you find out? Oh, and what did you find out? Am I going right 6 down 3 every time?
Yes.
Yes, we are. So this is a translation. So I'm just going to say yes, all points move the same direction and distance. It is a translation. All right, now I want you guys to get in the habit of writing it yourself now. I want to go through all different notations now of writing right 6, down 3. So let's do function notation first. X comma y. What do I write for right 6 now? Right 6. X, right 6. What do you want me to jot down here? Zach, what do you want me to write down? Right 6. What do I do? X.
X6, y -3.
Okay, x plus 6, and then y down 3 minus 3. There you go. There's function. Let's go practice vector now. Vector, you're just putting the numbers in. That's it. Telling me where you're going. 6, -3. That means right 6, down 3 in vector notation. And then one more using the capital T. Okay, hey, capital T means translation with a subscript of where you're going, right 6, down 3. Everyone all good? Yes, Quincy.
Are you ever gonna ask us for like a certain notation? Like
I could, yes. Yep. And you'll see that actually at the end of today's notes. All right, let's actually take a figure and translate it now. So I'll give you guys a second. Go ahead and graph triangle ABC for me. And you'll see now I'm showing you the translation in vector notation. So do we know what to do if I see -4, 1 in there? Along the vector -4, 1. All right, where am I going? Tell me direction and distance now. -4, 1 is in the vector there. Where am I going? Audrey, go ahead. Where am I going with this? What's the -4? Tell me.
That it goes through the line of x -4.
Oh, what do we say here? If I see -4, does that mean right, up, down, left, or right? If it's in
It
the,
means it's going left.
there you go, left 4, and then what about the +1 next to it, Audrey?
And it's going up 1.
There you go. So everyone, now I'm going to take A, B, and C, move it left 4, up 1. They're the image. Left 4, up 1. I'm way off. And also, I know it doesn't say state the coordinates, but let's write them down too. I know it just says the graph, but I'm going to add on here. I do want to just ask somebody what they got for the coordinates. So graph and state them as well. Hayden, here we go. What do you got for your coordinates, Hayden? When you're ready.
A is -2, 2.
Yep. How about B prime?
B prime is -1, 4.
Yep, and finish this off right. C prime.
C prime is negative 5, 4.
Good job, Aiden. Thank you. I don't know if you guys are noticing, you don't need to count on the graph. You can just subtract 4 from all your x's and add 1 to all your y's, and you get the same coordinates. All right, just a heads up on that. All right, so you don't have to go 1, 2, 3, 4, up 1. If you want, that's fine. All right, but you can also add and subtract them as well. All right, all good. Any issues? Okay, one more like this, and then I'm going to introduce what actually a vector is. So another triangle, but now new notation here. And then part B, go ahead, using this translation notation. Let's move our points. Let's move the points now. Three, -1. 3, -1. Where are your points? As you're doing this, where are your points moving? Give me a direction. Where are your points moving right now? Omni, where are your points moving?
They're moving to the right and down.
How many? Right, how many?
3.
Good job. Yep, right 3, down 1. So everyone, if you haven't done so, let's keep going. Right 3, down 1. And then this one does say state the coordinate. So I'm going to ask somebody here in a second. What'd you get for A prime, B prime, and C prime? Again, don't forget about the primes. Just don't call them A, B, and C on me. They're new coordinates now. All right, when you're ready, let's hear them. Let's hear them. Let's hear them. Zach, again, when you're ready, let's hear them. A prime, B prime, C prime.
A prime is 0, 3.
Got it. 1 for 1.
B prime is -1, 2.
-1.
2.
-1.
Sorry, -1, negative.
There you go. Good.
And then C prime is 1, 0.
Good way to rebound. There you go. All right, all good there. We're having no problems there. Now, part C, draw a vector that defines this translation. So I need a vector drawn. First, I got to know what the heck a vector is. That shows me that you went right 3, down 1. I don't know how many. Have you ever science? Have they talked about it yet? Maybe no. A vector is an arrow. Okay, and just I'm going to put it on the graph here. Please don't do it until I put it on the graph. Vector is an arrow. Here's what a vector does. Number 1, a vector shows you the direction you moved. So if I see this vector here, I moved in this direction. It also shows you how far you moved. However long the vector is, that's the distance I moved. So a vector serves 2 purposes. Shows you the direction you went and the distance you went, however long that arrow is. So how do I show on my graph that I went right 3, down 1 using an arrow? How could I do that? How could I place an arrow up here that shows that I went down, right 3, down 1? Got something, Kyla?
You put a point on the graph and then go down 3, or you go right 3 and down 1 and then connect the points.
So here's Kyla's suggestion, which is suggestion number 1. I'm going to have suggestion number 2 here in a second. She says just put a point anywhere on your graph. Go right 3, 1, 2, 3, down 1. And make your vector arrow off of that. Yeah, that's one way. Radhika?
Could you connect like 2 points like C and C prime or A and A prime and then just add an arrow?
Connect a pre-image and an image point. There's another way out too. So I could connect A and A prime and make that into a vector as well. Yep. Both ways are fine. Either one here, take a look. Either vector we wrote down, either one of the two still says I went down, I went right 3, down 1. All right, so there is what a vector is. Tells you direction and distance that you go. Any issues with the vector? All right, this one's go ahead.
You just draw that on the graph,
Yep, right on the graph I want it.
and you only need to draw the one.
That's it, yep. And it has to be on a graph because that's the only way I'm going to know it's truly right 3, down 1. Oh, I love this next one. This is almost like an honors level I can't get too tough in translations, but this is about as tough as I can get. All right, so I have 3, 3. The image of 3, 3 is 6, 1. So, hey, guys, I went from 3, 3 to 6, 1 using a translation. That's what it says, a translation. Okay? So think in your mind right now, where did I go to get there? Okay, I went from 3, 3 to 6, 1 using a translation. Up, right, left, down, how many? Think about that. Because you have to use that same rule to find now take a look at the directions. What did I throw in there? Find the pre-image, yeah. So in part A, I'm saying I ended at 8, 3. I ended at 8, 3. Where must have I started then, using that translation rule? And in part B, I ended at 2, -5. Where must have I started? Well, let me get you going here first. What did I translate? 3, 3 to 6, 1. Tell me where I went so I can write a rule here. Quincy, where did I go here? 3, 3 to 6, 1.
Like the distance.
Yep, and direction.
You went down to the right. Yeah, down to the right.
Okay, how many units?
3 to the right and 2 down.
Okay, 3 to the right, so I put +3, down 2, -2. So that was my translation rule. Do you guys understand the directions at home, what I'm looking for? All right, I ended at 8, 3 using the translation rule there, 3, -2. Where must have I started? All right, that's what I'm going to ask you guys. So think about that right now. Where did I start? I used 3, -2, and those are the 2 points I ended at.
This is assuming we're using the same translation rule for these two.
Correct, yep. It says using the same translation rule. So remember, guys, on part A and B, that's where you ended, not where you started, where you ended. All right, let's see what your thoughts are here. All right, Ellie, talk to me here. If I ended at 8, 3, where did I start?
I got 5, 5.
Good job, Ellie. Good job. 5, 5. Yep. I started at 5, 5, added 3, subtracted 2, and got 8, 3. Good job, Ellie. 2, -5. Where must I have started from? Luke, go ahead. Where did I start if I ended at 2, -5?
-1, -2.
Good job, Luke. What was your y coordinate there? -1?
-3.
Yeah, good job. Yep. Anybody want to talk that over here with me before we get to our last one? Good timing. Anybody? At home, you all right? And finally, we got the old marching band. Got the old marching band rocking and rolling. Anybody? I got any bands here? Band? I heard Will. I heard about your legacy from my first period class. You too, Hannah? What do you play? Clarinet. How long you been playing? Not wow. I heard percussion. How long?
Well, I've been playing percussion for about 4 years, but I also play piano.
Wow. Dual, huh?
Yeah.
Wow. Anybody at home want to chime in? Instruments? We're having a nice discussion here.
I played piano for I think 8 years.
Wow. You still do, Sophia?
Yeah, but I'm not in a band.
No, I know, but Still pretty impressive. I always, just so you know, I'm not cracking jokes on the band camp kids. I envy all of you because my instrument experience was 5th grade 1 year with the baritone, and I was out. That was it. See ya. I'm good. Okay, so that was my band experience. So you guys got a lot of respect for. All right, so going to our band, marching band here. You guys see I got 3 positions, and in case you guys needed it, I got left, right up there for you, in case you needed it. Forward, yep, no problem. Always thinking of you guys. Forward and backward. So here's what I want to know first. How to get to position 1 to position 2. First, I want it in words, like right, left, this many units. And then I want it in function notation that we discussed earlier on today. Hey, I don't know if anybody noticed, you better heads up here. Anybody see the scale? Yeah, better be careful there. Going by 2s, not by 1s. Be careful, kids. And yes, you can assume that those points are in the middle. Yeah, we're going by 2s here. So in your own words, I'm going to ask somebody first. How am I going from position 1 to position 2 in your own words? Make sure you give me a distance and direction. All right, when we're ready here. 10, what do we got? Atticus, when you're ready. Distance and direction. How do I get from position 1 to position 2?
Left 12.
Yep. And that's it, right? Left 12. You're not going up or down any there to get to position 1 to 2. Everyone's good? Now, how do I write that in function notation? X, Y. I always start function notation off with X, Y. Implies, now do this to it. All right, how do I write? I'm going to go left 12. How do I write? I'm going to go left 12. Sophia, how do I write? I'm going to go left 12 on you.
X minus 12.
Good. Yep, X minus 12. Now, I didn't do anything to the Y. It can't disappear, though. It can't disappear. You can just leave it Y, which says I didn't do anything to it. I'm just keeping it. Or, if you want to, yeah, you can write Y plus 0. It didn't go anywhere. It's up to you. But you just can't have nothing there. I need something with the Y there. All right, so nice job, guys. And last question for you. Now go from position 1 to position 3 for me, but write it as a translation vector. Okay, write it as a vector now. All right. Take your time here. This one's a tough one here because you got them right in the middle there. Emily, when you're ready, where am I going to go from 1 to 3?
Is it 9 down and 12 to the left?
Okay, you got the right wording for me now. If I want to go 12 to the left, how do I write that in my vector?
-12.
Yep. And then if I go down 9, what do I have to write?
-9.
There you go. Yep. Just make sure the -12 comes first, everyone. Remember, right and left, since it's on the x-axis, always come first. All right. Any questions, comments, concerns? Yes, what's up, Hannah?
Do we not think the arrow because it's like translation vector, not vector?
Correct. When you actually draw a vector on the graph is when you do the arrow. Yep, this is the notation for a translation vector. Correct. Yep. Okay. You know what, guys? There's no why am I keeping you guys? You guys at home, go stretch, go grab a drink of water, whatever. All right, and I'll see you tomorrow. All right, just get the homework done for me. I'm not going to keep you another 10 minutes to do the homework. All right. So you guys take care. I'll see you tomorrow. You guys here, if you want to start the homework, fine. If you got something else to do, fine too.
Is this gonna be a graph paper too?
Yeah. Oh yeah. Yep. And just pay attention to the directions on the homework. All right, because there's some. As I'm looking at this now,
Why are you doing after school help Monday?
Monday.
Yeah.
I should be. Why?
Swamp.
Yeah.
Eagle. The one that's like right across from me. Did you have notes on my